On this episode of On.NET, we're going to be looking at ASP.NET Core performance challenges, and you can learn about new techniques that you can apply to your app. Hello, welcome to another episode of the On.NET show. Today we're going to be talking to Mike Russo about diagnosing ASP.NET Core performance challenges, particularly cross-platform. So Mike, how about you introduce yourself and then we'll get into the topic.
Yeah, absolutely. Thanks, Rich. So like Rich said, I'm Mike Russo. I'm a developer on the DevDiv customer engagement team. We're a part of the engineering organization who works with customers to make sure that they're able to successfully adopt some new DevDiv technologies. I specialize in .NET Core, but also work with Azure, VS, and so on. We make sure customers get off on the right foot, then we bring back what we learned and make the product better through fixing bugs, blog posts, documentation improvements, etc.
Right, basically whatever the customers need.
Yes, that's right. We figure out why this customer is having challenges, and then we make it so other customers don't have the same problem.
Right, and so do you work with, say, one customer at a time, or is it multiple?
Typically just one at a time. We'll work with one customer from anywhere from a week to a month or more till we've sort of worked through their particular scenario. Then we'll take a couple of weeks, write up what we found, and drive improvements back into the product, then we'll be off on another one.
Wow, so is there kind of like some bat phone, like, I want Mike to work with me?
You know,
I have the need.
I don't know if there's a bat phone, but we get leads from a lot of different places. We get them from the field. A lot of times our director, Jay Schmelzer, will just hear about it from folks on other folks in the engineering team, or meet someone at a conference. It really come from any number of channels.
Okay.
But, yeah.
So let's get to the topic. So it sounds like with one of the last, some of the last customers you've been talking to, you've been diagnosing ASP.NET Core performance challenges,
Yes.
and I'm hoping you were able to get them on a good path.
We were, yes.
So tell us about the specific challenges you've been looking into.
Yeah, absolutely. So, when we look at ASP.NET Core, one of the things that comes up a lot is that customers don't know how to go about diagnosing issues in staging and production environments, because a lot of times that's on Linux, it may be in Docker containers, and a lot of the people we work with have .NET experience, but they don't have as much Linux experience, and so they're not sure what tooling is available there, and they're not sure how to get started. So that's one of the things I thought I could kind of demo today, is show a little bit how we do that, what tools are out there. And then we can also, as we're doing that, maybe talk about some of the problems that come up most frequently. It's, every time we work with a customer, it's kind of unique, and performance problems are seldom just one root cause, but there are definitely classes of things that come up more often, and so it's worth calling out as, sort of common things to look out for in your own apps.
Right, so is it the case that, some of these customers just don't know enough about Linux to be successful, or is it the case that you should give feedback to the ASP.NET Core and .NET Core teams to say, your products aren't as diagnosable as they should be? What is the forward-looking path in this space?
Yeah, I think a big part of it's actually just the documentation. It's a lot that, customers understand how to use Visual Studio or other tools to diagnose things on Windows, and we have tools for Linux. They're available, but up until very recently, they weren't well documented. Or if they were documented, it was in some GitHub repo, where if someone like myself tells you, hey, go check out this doc on GitHub, you're great, but without that, you're not going to find it. So we've been doing a lot of work recently to actually beef up that documentation so that someone new to ASP.NET Core, as they go through the docs, would be able to find those pointers and get ramped up.
Makes sense. Okay, let's start. Let's look at some stuff.
Yeah, awesome. Let me go ahead and share my screen here, and we can go through a little demo. Let's see.
You're going to give us some performance challenges? Is that it?
Yeah, I've got a sample app I made. In fact, here, maybe I'll even start with that. I made an app that demonstrates 3 of the more common problems I see in customer code. Are you able to see this all right?
Yep.
Okay.
I think we're good. Perfect.
Now, this is a little bit of a contrived demo because I tried to make it short but fit in a lot of different challenges. But basically, it's just a simple ASP.NET Core app, goes and gets data from a SQL database. Specifically, I'm using the AdventureWorks data, which is one of our sample data sets. And this API here, which is called test1, it goes out and it gets all of the products in the mountain bikes category with this first SQL query, which is this. Then we call some external service for each of the mountain bikes to find out whether or not it's in stock. For each of the mountain bikes that's in stock, we then do a follow-up query to get a thumbnail photo for it, and ultimately we're returning an MD5 hash of the photo of each mountain bike that's in stock. So again, a little bit of a contrived sample. I don't know anyone who actually needs to return an array of MD5 hashes for in-stock mountain bikes, but it's an example of something someone might do in ASP.NET Core that kind of showcases some of the stuff that I think can be problematic.
Right, so what I hear you saying is the app is contrived, but the specific performance issues that you're running into here are not contrived because they're based on actual apps that you've seen in the field.
Yes, that's right.
Okay, good.
Yep, that's exactly right. So, I've got a few slides here with links that I can go through briefly, but the thing I want to really focus on here is kind of these bottom two, because people are already sort of familiar with the value of having in-app performance monitoring with something like App Insights or any number of other options like New Relic or Dynatrace. That's kind of the place to start. And then after that, you would go and use kind of the tools in your IDE, like Visual Studio 2017's diagnostic tools, which are super useful during the just code test debug cycle for ferreting stuff out early. But people know about these already. Where I think we can add the most value is really letting people know about PerfView if they haven't used it before, and then more than PerfView, PerfCollect, which is a script that allows us to gather performance information in a cross-platform way so that we can go in and do some deeper diagnostics. And so, if people haven't used them, these are definitely tools worth looking into. Also, I did check in my contrived sample on GitHub, so if you want to go out to MJ Rousos, the ASP.NET Core Perf anti-patterns, you can get the terrible code for yourself, but it's out there. But the tools that I think are useful are PerfView, which this has been around for a few years, so people probably know about PerfView. But it's a performance analysis tool for .NET for identifying CPU issues, memory issues. It shows you ETW events, all of that. If you haven't used it before, it's a really great tool to become familiar with. We've got some video tutorials you can go check out. Just go out to Microsoft PerfView. But the challenge that some of the customers I've worked with recently run into is that PerfView only runs on Windows. So when they have a performance problem that only reproduces in their Linux staging environment, they don't know how to start with that. That's where PerfCollect comes in to fill a gap. So PerfCollect is a script that you can download. You just curl it down, curl, aka.ms PerfCollect. And this script uses native Linux profiling tools like perf and LTTNG to gather traces that PerfView can consume. So on your Linux machine, you hop into your staging environment or even your production environment, you download PerfCollect, you run it for a minute or so, then you take the zip file that it generates, copy it back to your Windows machine, and you use PerfView like you're used to. And so that's the thing that I can demo quickly here just to sort of show you what that looks like.
Great.
So let's go ahead and do that. So
and are some of the customers that you're working with, are they doing just that?
Yes, they are, and they've had good success with it. So yep, it's worth knowing about. So I have deployed that app out to a Linux VM up in Azure, and it occurs to me that this text is probably small, but actually it's not. I'm only going to be typing a few things. The first thing I'm going to do is I'm SSH'd into that VM, so I'm just going to, I'm going to start the app. So we'll go out to source, ASP.NET Core Perf anti-patterns, and then my combined demo. Out here, I will run the app. Then once that app has started up, we can confirm that it's running by just hitting the endpoint that we were looking at earlier. So I'm doing a curl to the test1 API. And you see we get back a bunch of MD5 hashes, which in themselves are not interesting, but says, okay, this thing's working. So that's good. So what I want to do now is I want to run PerfCollect, and I've already installed PerfCollect on this machine. That's just a matter of copying down the script, running PerfCollect install to actually install the tools that it uses under the covers, and then a couple other steps that are well documented on that GitHub site that will explain how to set it up to get symbol information for .NET Framework and .NET Core stuff if you need that. But that's already installed. So what we want to do, the one other thing you need to do for PerfCollect to be as useful as it possibly can be is you do want to have a couple environment variables set. So specifically, there's 2 of them. So I'm going to restart my app with a couple environment variables set now. I'm going to set com plus perfmap enabled equal to 1, because that's going to instruct the JIT that when it JITs a managed method, it needs to also emit a map file that will allow us to map back from some CPU sampling data to where this was in managed code. Okay, and then the second one we're going to set is we're going to set com plus enable event log to 1. That's going to instruct the runtime to emit ETW events about stuff like garbage collection, threading, jitting, and so on. Now, setting these is going to slow down perf even more, so you don't want to have these set all the time. But if there's a particular problem you're running into, you can take one instance of your app or one instance of the container, take it down, set these environment variables, put it back up, restart the app, collect some data, and then sort of undo it all. So that's kind of the process that I'm going through here.
Now you said ETW event, but we're clearly on Linux here.
We are on Linux, yes. Actually, I suppose they're not actually ETW events here, but the runtime is able to emit the same events in a cross-platform way. So they wouldn't really be ETW, but they're still emitted in a way that tools like LTTNG can pick them up and report on them.
Right.
Yes, good clarification.
Yeah.
Now, in the real world, what I'd probably do here is I would use Visual Studio perf and load tests to apply a load to this. I don't know if people listening to this have experience with those tools, but they're pretty nifty. You can have a whole script of like the requests you want to make, and it's the pretty sophisticated product. And you can run stuff up in Azure, so you can have like a bunch of Azure VMs beating on your service to apply load. But it takes a few minutes to upload and start that up. So in the interest of time, I'm just going to run some load tools from the command line. So this could be, Apache Bench, JMeter, anything. In my case, I'm just going to run Siege. And I'm going to tell Siege to have 50 users continuously calling this API for 1 minute. 50 users isn't even very many, but it's a terrible API, so we'll immediately see problems. Okay, so I start this. So now we've got people hitting the API. And in fact, before I even run PerfCollect, I'm going to use top to look at what's happening with the CPU usage on this VM. And I can see, okay, now .NET's up at the top here, as you'd expect, because it's processing these requests. But I notice immediately that it's got very low CPU utilization compared to what I would have expected. And so this is indicative that we're not making good use of the hardware. There's, maybe threads are blocked, or we're doing something that's not actually useful. So that's something we'll want to look at later. But what I'll do right now is I'm going to run PerfCollect.
Right, and for those that don't know, top is basically a command line version of Task Manager for Linux. Yeah. If you're coming from
that's all it is.
A Windows background.
That's right. Yeah, good point. But so I've looked at that. Okay, so that's a little fishy. But then PerfCollect is as easy as just running the PerfCollect script, collect, and then you give the trace a name. You only need to run it for usually 20 or 30 seconds to get some good data, as long as your app's in a state where it's demonstrating the perf problems. And then once you're done collecting, you hit Control-C. It does some post-processing. It takes a minute or two. And it gathers all the stuff up into a zip file, which then we can bring back to Windows and we can analyze. Meanwhile, over here, we see that Siege finished up. It said it served 5 requests per second, which is terrible. Okay. That's to be expected. While I wait for this, I can show also I did earlier. Let's see, where is it?
What tool do you use to move those zips around? Like I would use SCP.
That's exactly what I use is SCP. It's just simple command line tool for.
I have to admit, I really love that tool.
Yeah, it is. It's super useful. It's it's very handy. Do I not? Oh, here it is. So I was going to show the output from some load tests as well. So I mean, I'm using Siege here, but if we had 10 more minutes, I'd be showing you VS load tests because you can get information about, sort of throughput over time. And actually, this is an interesting chart because you can see that our throughput with my API was very spiky, which is another kind of interesting symptom because it means that periodically something's happening that's causing everything to kind of slow down or halt, and then it's okay for a while and it slows down again. So I mean, this is another useful tool to look into. Is just the Visual Studio perf and load tests and the Azure DevOps integration there.
Makes
Anyhow,
sense.
this is now. So um, the interesting thing about this is it's just a zip file, so I can unzip it. And I mean, you wouldn't normally do this because you don't have to, but just in the interest of demoing what's in here, we can step into the contents of that zip file. And if we look at what's here, you can see we've got some perf.data files, which are the sorts of stuff that the Linux native tool perf will gather for us. We also have these map files that I was talking about that allow us to correlate information in that perf trace back to managed code. And this is all stuff that's understood by native Linux tools as well. Now, I'm not super familiar with them, so I'm not going to do much debugging in it. But if you are familiar with things like perf, you could just run perf report on this same data that we're going to use in PerfView, and it's able to understand it as well. So you could come in here just from the command line and start looking at, okay, where's time being spent, so on and so forth. And this console's too little, but you can start to see interesting things that are taking time and so on. So just interesting to note that works that way.
Very nice. I'm sure there's some people who are super happy watching that.
Yeah, say, oh yeah, oh great. I'm already familiar. I can take advantage of it, and it all works with .NET Core the way you would want it to, which is great. So I'm going to go ahead and start up PerfView, and we can look at that briefly. I'll try to keep this quick. I know these demos aren't supposed to be too long, and this one gets a little lengthy. But what I'm going to do is I actually already copied something over with SCP earlier. It's the same as what I just gathered, but rather than waiting for 100 megs or whatever to copy to my machine, I've already got one here we can look at. And I'm just going to briefly go through a few things in here that are interesting. So the first one is when you open up PerfView, there's going to be a section here for CPU stacks. This is just sampling information that shows where time was spent in your application. It shows the call stacks. You actually get like a flame graph, which in our case, I'm going to quickly drill into just the process we care about. In this case, I don't think the flame graph is super useful, but in other scenarios, it can be helpful. But what it allows you to see is you get both exclusive and inclusive information about how much time was spent in each one of these stack frames. Exclusive information is how much time was spent specifically in this frame, whereas inclusive is how much time was spent in this frame or in something it called. So you can either do kind of a bottom-up approach where you sort based on exclusive time and you start looking at, okay, what was taking time and how did we get there? Or you can do more of an inclusive analysis where you start from the top and work down to see where time's being spent. And again, PerfView is a kind of complex tool, so I'm not going to get into all the details now, but we've got a lot of videos online for someone who wants to learn about it. I encourage people to go check those out. In this case, though, if I do, let's just sort by stack frames, inclusive time, at the top you see a bunch of ASP.NET Core MVC stuff, which is to be expected because every request is coming in through your MVC pipelines. It's going through your middleware, through the MVC routing, model binding, all of that stuff. So that's always going to be up at the top here. But as we get down, we'll look for where our app starts to show up. We can see, okay, 60% of the time when we sampled, we were in this get in stock thumbnail hashes 1 API, which makes perfect sense because that's the controller action for the one API we were calling in our load test. So we expect to see this on here. But we can go to the callees tab to see what this thing was calling and where it's spending time. One of the places where we see it spending time is in System Data SQL client. We can drill in here. We can see it's spending a lot of time getting connections from the DB connection pool. And so there's something going on here. Now, just seeing SQL connections is not necessarily a red flag because that's commonly a slow part of an ASP.NET Core app. But seeing it so much at the top of the list makes us want to go look and see, well, how are we using SQL? Is there something that can be optimized there? So this is where you might hop over into Azure and look, I'm using Azure Sequel, so I can get some telemetry there about what SQL stuff we're doing. And we can come in here, we can start to notice interesting patterns like, hey, there's some query that we're calling 11,000 times, in the past minute or two. That's suspicious. And so you can come in here, see what that query is, select thumbnail photo from product where product ID is whatever. And then we realize, oh yeah, we're doing something dumb in our app here that we really shouldn't be doing. After we have the list of the mountain bikes that we care about, and we've filtered it based on what's in stock, we're making a separate SQL query for each one of those products to get its thumbnail photo. So that's pretty inefficient. This is that query that we saw coming up 11,000 times in Azure. So this is something, we've got the SQL query inside of a for each loop, which I've never actually seen in a customer app, but it's a simple way of demonstrating something that I do see a lot, which is APIs in their ASP.NET Core apps that are hitting SQL databases, remote services, whatever, multiple times per request. It could, in some cases, I see someone making a request and it results in 10 or 20 different calls to backend stuff. And this is where your time is often spent in ASP.NET Core apps. So you want to really minimize that. So this could be minimized. I've got a fixed version of this API down here by having a different query where, okay, you know what? We're going to do one query for all of those products instead of querying them one at a time. Other things you can do here is you can cache. If there's some data you're getting from a database or a remote service that's acceptable to be stale by, say, 1 minute, you can cache it for a minute, and now that's going to save you a lot because you're avoiding these slow remote calls. So that's one type of thing we would see here. The other thing I would look at in PerfView, and I'll keep this moving here, but we've got this events tab where you see those events that we talked about earlier, ETW events on Windows. I don't know what they're called on Linux, but they're events. And there's interesting stuff here about the GC, thread pool, et cetera. One that you always want to look at in an ASP.NET Core app is the thread pool health, because ASP.NET Core apps are very multi-threaded. You expect to have a small number of threads handling hundreds or thousands of concurrent requests. So if I look at this particular event, the thread pool worker thread start event, this is going to show me every time a thread was added to the thread pool. Well, I see that's happening pretty regularly. Every second, on the second, we're adding a new thread to the thread pool. The thread pool can only add threads about once a second because of the way its algorithms work. That's the way it functions. And so this tells me that over the course of the 50 seconds or so that we were profiling for this trace, we were expanding the thread pool as fast as we could. And that's generally a bad sign. That, combined with what we saw earlier where we weren't using a lot of the CPU on my VM, tells me that we are probably starving the thread pool. So these threads are busy waiting for something, and they're not able to handle new incoming requests, and we don't have threads available to take care of them. The very common cause of this is not making things asynchronous. You have blocking calls that could be non-blocking. So if we come back to our app, sure enough, you notice this API here is not async. I'm making SQL calls. I'm connecting the database, executing the reader and stuff, not in an async way. When I look to see whether products are in stock or not, I'm calling an API called product is in stock async, and then I call .result on it. That's a red flag. Anytime you're calling .result or .wait on a task, that's something that could have been done in an async manner, leaving that thread free to handle a different request. And instead, this thread's sitting here doing nothing until we hear back from some remote service, which could potentially be slow. So that's one you definitely want to look for. And then the last one briefly is, along with those ones in PerfView, we also have this memory group where you can get GC stats. This will show when the garbage collector ran, why it ran, et cetera. And this is worth looking at. A lot of times people will start engagements asking us, hey, is it a GC problem? And it's often not. And so you don't start there unless you have data, but sometimes it is. And so it's worth looking here to find out. And in our case, we profiled for about 50 seconds. We had 114 GCs, and 92 of them were Gen 2 GCs, which is bad because Gen 2 GCs are slow. They require pausing the application. In fact, you can see that we were paused 17% of the time the app was profiled. It was paused for garbage collection, so we weren't processing any requests. This lines up with that real spiky performance we saw earlier where things are okay for a moment, then they're terrible, then they're okay again. Those terrible times when we were doing a Gen 2 GC. So if we scroll down, we can see why we were doing these GCs. In this case, it was all allocating large objects. Large objects are anything bigger than 85,000 bytes, so typically that's an array. And they're allocated on the large object heap, and when they're cleaned up, they have to be cleaned up with a Gen 2 garbage collection. So the thing you want to look out for here is if you see a lot of Gen 2 GCs happening, you may be allocating more large objects than you really need to. In our case, the issue was we're getting these thumbnail photos out of SQL. They're potentially large. So when we read them, we're allocating a 100,000 element byte array to read these thumbnail photos. And we're allocating a new array each time. We're then immediately throwing it away. And so the garbage collector is just going nuts trying to clean all these things up. Again, caching comes to the rescue here. Another option, if it's not something that makes sense to cache because it's not used frequently enough, would be to use array pool of T. This is a relatively new API, so a lot of people don't know about it. But with array pool, you can rent a large array, use it for whatever you need it for, and then return it to the pool. And it doesn't have to get cleaned up because the next time you need a large array, like the very next time someone makes this request, you can request an array, get that array back, use it again, and you don't have to keep allocating and deallocating large objects. So that can be super useful as well. So I mean, that's basically the demo. Again, there's a lot more that can be done with PerfView and PerfCollect, but I just wanted to kind of cover some of these. Just kind of recap. Make sure you're not blocking calls that could have been asynchronous. Got a great blog post here by Vance about why that's so bad and how to avoid it. Look out for chatty interactions. Making calls to databases and remote services is slow. Do it as seldom as you can, and do it in as efficient a way as you can. Don't get extra data if you don't need to. And again, we've got caching APIs that can help with this. And then finally, just look out for memory issues if you're allocating a lot, especially if you're allocating objects that are going to be more than 85,000 bytes. That's something you want to try to be really careful with. And we've got array pool to help with that. Also, if you're working with strings or large arrays, you can use span of T in ASP.NET Core 2.1 to help. You can even stack alloc short-lived things starting in C# 7.2 and then added some functionality in 7.3. So anyhow, that's just kind of a quick demo of some of the more common issues we see, and hopefully it's helpful to people to know sort of what to look out for and how to diagnose stuff.
It's very helpful. So is there a kind of a good news story, though, to your particular app?
Yeah, there is actually. So,
kind of worst case
if you
scenario.
go out and look, I called this API that was terrible, I called it test 1. In test 2, I have the same API, but I started using array pool. In test 3, I took test 2, but I now made the whole thing asynchronous. And then in test 4, I consolidated it down to just 2 SQL queries instead of many, which 2 is actually still more than I'd like to see, but it's way better than like 40 we were doing before. And in fact, I ran a load test on that as well. So whereas before, we had an average response time of 4 seconds, which is kind of laughable, and this very off and on performance. Once I run the thing against test 4, I ran it with 500 users instead of 200, but despite having 500 users, our average response time is down under 50 milliseconds, and the chart is exactly what you want to see. As more users arrive, throughput goes up, and it never really varies from that increasing load. So yes, there is good news, and the good news is that just fixing up these few things makes a huge difference in this sample app. And of course, like I said, this is not a real app, but the problems it's demonstrating have really shown up. I mean, even just to kind of briefly go through, examples, there are places where we've seen customers flushing App Insights every time they log something. When you flush App Insights, that involves taking a lock. That's another version of the blocking problem. The thing where we're getting images from a database, that's real. We've had people get images from databases, convert them to base64 strings, and then throw them away. So things like this do come up, and these sorts of fixes do make a big difference.
Right. So what I kind of hear you saying is these fixes are actually not hard, meaning you don't have to be a rocket scientist. You just basically need to read the right guidance, apply the right pattern or technique, and then you can really have a much better performing app than you had before.
Exactly.
Yeah, that was like 10x improvement on latency.
Right.
Yeah.
Yeah. It's a big difference.
Okay, so any kind of closing statement that you'd like to make before we finish up for today?
No, I think we've pretty much covered. I suppose in closing, I can point out that we have actually been trying to capture a lot of this in documentation. It's a place where in the past we haven't had docs, and that's why customers have struggled. But we've taken a lot of the same things we've learned about that I've discussed in this conversation, and we've put them up just recently on our ASP.NET Core docs site, so you can go out and check out our performance overview. And we go over a lot of the same stuff, along with some other ones too that maybe were tier 2 issues that we didn't have time for here, but are still interesting to know about. Don't use exceptions for code flow. Minify stuff that you're delivering to clients, pool HTTP clients, all sorts of stuff. So you can go check this out, and hopefully it's a useful resource.
Okay, thanks. Well, this was awesome. Being able to get effectively like battle-tested, customer-related feedback on how to deal with performance challenges. So thanks for being on the show, Mike.
Yeah, my pleasure. I'm happy you guys had me on. Appreciate the opportunity.
For sure, for sure. Well, maybe, you know, in like 6 months or a year or something like that, we'll do V2 of this and see
Yeah, that'd be great.
See what other things you found. Okay. And thanks so much for watching another episode of On.net.